A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hello. It is always interesting to learn about circles. We can see many objects around us which are in the form of circles. There is a competitive item named thread pattern making in science exhibitions. There we can see students making different shapes using the thread. In some patterns, we can see the formation of circle, which is interesting to watch. So, circle is such a figure which involves lot of interesting properties. Let us learn some of them. Let us try to draw a right angled triangle with a hypotenuse of 5 cm distance. What can be the values of other sides? The angle which is opposite to the hypotenuse is always a right angle. We know that the sum of the angles of a triangle is always 180 degree. The one angle of the triangle is already 90 degree. So, the sum of other two angles, that is the angles which is on the two ends of the hypotenuse, which is 90 degree. So, if one angle at one end of the hypotenuse is 1 degree, then the other will be 89 degree. Similarly, if one angle is of 2 degree, then the other will be 88 degree and so on, like the table shown here. So, the table of different combinations is shown here. So, let us draw the 5 cm hypotenuse first. Then draw different right angled triangles of different angle combinations. So, by using these different combinations, we got different right angled triangles, which is above and below of the hypotenuse. Now, this figure is looking like a circle, right? But we didn't draw any circle here. The circle is formed by its own. Let us rotate the figure as shown here. Now, the circle is clear. Mark the midpoint. By using this midpoint and 5 cm as diameter, let us draw a circle. The circle formed is going through all the 90 degree corners of the right angled triangles. And this is the same circle we saw during rotating the figure. Now, let us consider a circle with center O. The diameter of the circle is AB. The endpoints of the diameter, that is A and B, which makes an angle P with a random point on the circle, which is shown here. We already saw this angle is right angle. Now, let us mathematically prove that this angle is a right angle. To prove that, join the points O and P. Now, the angle P is divided into two small angles. Similarly, triangle APB is divided into two small triangles, that is triangle APO and triangle BPO. In the triangle APO, AO and PO are radii of the circle. The two radii of a circle is always equal. So, AO must be equal to PO. So, the triangle APO is an isosceles triangle. In an isosceles triangle, two sides and two angles will be always equal. Now, let us assume the angle in the point A is x degree. If A is x, then angle APO will be also x degree, as the triangle APO is an isosceles triangle. In the triangle BPO, BO and PO are radii of circle. So, BO must be equal to PO. So, the triangle BPO is also an isosceles triangle. Now, let us consider the angle at the point B is y degree. Then the angle OPB will be also y degrees. Now, consider the bigger triangle APB. The sum of the angles can be written as x plus y plus y, and that must be equal to 180 degree. That is 2x plus 2y equal to 180 degree. Taking 2 outside, 2 into x plus y is equal to 180 degree. That is x plus y is equal to 90 degree. So now we proved that angle APB is right angle. That is, now we mathematically proved that angle APB is right angle. Now we can conclude this as, if we join the ends of the diameter of a circle to a point on the circle, we get a right angle. That is, angle in a semicircle is always a right angle. This point can also be said like this, that is, if we draw a right angled triangle from any point on the circle, the sides of that right angle will pass through the end points of the diameter. If we join the end points of the diameter of a circle to any point inside the circle as shown, what will be the condition? Now let us extend the line AP to meet the circle at the point Q. Then join QB. Now we want to find the value of angle APB. The angle APB is external angle of the triangle PQB. Now in any triangle, the external angle is the sum of two opposite internal angles. That is, here we can say that the angle APB is the sum of angle Q and angle PBQ. We know that angle Q is 90 degree. So angle APB is equal to 90 plus angle PBQ. From here we can say that angle APB is greater than 90 degree. That is, here we can conclude this as, if the end points of the diameter of a circle meet at a point inside the circle, the angle formed will be greater than 90 degree. Now let us check what if the end points of the diameter meet at a point outside the circle. The lines drawn from the points A and B meets at an outside point P. Let us find the importance of the angle APB. Let us mark the point Q on which the line AP meets the circle. Join BQ. Consider the triangle PBQ. We know that AQB is the external angle of the triangle PBQ. Again, external angle of a triangle is always the sum of two opposite internal angles. That is, angle AQB is equal to angle P plus angle PBQ. So angle P is equal to angle AQB minus angle PBQ, where angle AQB is 90 degree. So angle P is 90 minus angle PBQ. We can conclude that the angle P is less than 90 degree. That is, if the end points of the diameter makes angle outside the circle, then it will be always less than 90 degree. Now let us conclude all the 3 points we learned. If the end points of a diameter makes an angle with the point which is inside the circle, then the angle will be greater than 90 degree. And if it is on the circle, then the angle will be 90 degree. And if it is outside the circle, then the angle will be less than 90 degree. This can be explained in another way as well. All pairs of mutually perpendicular lines drawn from the ends of a fixed line meets on the circle with that line as diameter. Now let us think in reverse. If we draw mutually perpendicular lines from a point on the circle and join the points where they cut the circle, do we get a diameter? Let us consider a circle. Also consider a point P on the circle. From the point P, draw two mutually perpendicular lines. These two lines meet at the points Q and R on the circle. If we join the points Q and R, then triangle PQR is a right angled triangle, and the circle is the circumcircle of the triangle PQR. A circumcircle is a circle which passes through the vertices of the triangle. So the line QR is the hypotenuse of the right angled triangle as well as the diameter of the circle. By using this concept, we can find the center of a circle which is unknown. Draw a circle by using any object which is in the shape of a circle. By using a set square, mark the points where the perpendicular lines cuts on the circle. Join these 2 points. The line joining these 2 points is known as the diameter of the circle. Now draw another diameter by using same method on another point on the circle. The point where the 2 diameters meet is known as the center of the circle. Here we learned some basic concepts of circle. All the activities in this chapter will be under the icon Maths Lab.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.